Peter McDonough, I've asked him to do a few edits here in the website, and for some reason the edits that he's been making are not showing up in the main page. So, for example, so problem set 1 is where it should be in week 7. Problem set 2, for whatever reason, is still sitting up there in week 6. So Peter has told me that he's moved it several times and it keeps going back. So I don't know if it's a Moodle issue or what. He's a pretty sharp guy. But anyway, let's just take a look at problem set 1.
For employee and student?
No, it's all Moodle 3. You can't, as a student, you can't make edits.
Sign in, yeah.
As a student, you can't make edits, but it's all the same software. Okay, so here's problem set 1. Six problems, and the majority of this is in the textbook. If you go back in terms of the units conversions, those are in. A lot of them are in table A5 and table A6, energy conversions. And that's really what you're doing right here. Yeah, your powers of 10 are all there. So if you remember, and we did this before, and I'm not going to hold you to the exact amount, if you eat 2,000 calories a day or 2,200 or maybe eat 5,000, I don't know. It's really an exercise in units conversion, not the specifics. So I want to see that you can go among 1, 2, 3, 4, 5, 6, 7 different energy units. They're all in the book. And this actually might be a good way to get started with Microsoft Excel. I don't want you to abandon the pencil paper method. If you want to do a combination of both, that's actually what I would recommend. Would just be sit down. Let's just say we start with 2,500 calories, big C calories. We know right away that that's going to be 2,500. Add 3 zeros for little c calories. And there are a lot of different sites out there for units conversion that you can take. I mean, there you go, right here, right at the top. The stuff it just gets easier all the time. You type it in, and one number goes in, and another one comes out. So if we click on kilocalorie, 2,500. There's your joules, 10.4 million. So you can do it this way. I also recommend you just go right to that table. If we look, let's see, so calorie, I guess calories are not mentioned in the book there, but the other ones are kilowatt hours there, BTUs are there, megajoules are there. So for the rest of it, you can just go right in and say, for example, 1 megajoule is 0.948 thousand BTUs, and kind of on down the line. So dig into that. The next one is express the amount of energy that the average human uses technologically in calories. Go back. I mean, the number that I kind of use off the top of my head is 500 exajoules per year. I know it's in the textbook as well. There's another paper out there. We read this paper for 102, but if you want to just take a look. It's a really neat paper out there. Proceedings of the National Academy of Sciences, Shramsky, published this a couple of years ago. It is free for download, if I'm not mistaken. And really cool graph right here. This is a lot like Summary 3. Just shows human population in blue. And they've been able to plot this all on the same scale. So it's in billions of people. So the granularity on this graph is very low, obviously. But there's the human population. Here's energy consumption. Now they put it in terawatts. You know how to convert from terawatts to joules. You just multiply your watts times seconds to get joules. So you can convert that. And kind of the interesting thing they've shown here is that it looks like human technological energy per capita actually peaked a couple years ago. Now, that can be due to one of a number of things. Either we are running out of energy, maybe we're running out of money, so we cannot afford to put in as many energy technologies, or we're just simply more efficient, or some combination of all three. It's kind of up to you to figure that out. But so that's problem 2. Problem 1 is about your metabolic. It's what you eat on a daily basis, and problem 2 is what you consume technologically. Keeping the house warm, the lights on, the car fueled, computer charged, cell phone charged.
To make these questions more specific to us than like the average human, or do the average?
Do the average human. Yeah. There are also some neat charts out there on what it looks like on a country by country basis as well. There's some countries that use a lot more energy per capita than some others. And again, it's either because they're living somewhere where it's really cold, maybe they're living somewhere where it's really hot.
So do you want us to give like citations of where we got our like numbers?
You should, yeah. If you found it, it's for your own benefit too. Yeah, if you found it somewhere, use a citation. That's a great question. Yeah, please.
An opportunity to personalize it in solar and wind energy. That's where you take your own electric bill and break it.
Yeah. But yeah, do go ahead and cite where you got your data. Okay, and then this third question is more or less question 1 repeated. You're just going to either multiply or divide by the appropriate factor, and then the same thing. I mean, so question 3 is basically the same as question 1. Question 2 or 4 is the same as 2. It's just going to be a factor of a coefficient that I'll allow you to find. Yeah, okay. So and this one too, fairly simple. You're just going to convert from energy to power. The results may surprise you. How little energy it takes to run a human. And then the same thing. The answer to this question is more or less on that Shramsky paper I just showed you. So there you go. So that's problem set 1. And again, be quantitative. It's not that difficult in. Let's go to the end here. It's not that difficult in Microsoft Word to write out equations. One thing I do suggest you do is 2,500 calories, not 2,500. Sometimes I see that. You forget to put a space between the units and the number itself. Another thing that's kind of handy, you might put 1.5. I like to use this times 10 to the 9th. Not 1.5 x 10 9, right?
That's not even.
Yeah. So anyway, I mean, it's just common typos. You might know what you're saying, but to convey it properly, you need to express it. Any other common pitfalls on that? Yeah. Oh, one more thing, while we're on the topic of summaries and numerical writing. Your summary 3 will require you to have a 300-word narrative along with it as well. I just don't want to see the figures, so just thought I'd mention that. Okay, so we've covered both summaries, and we've introduced you to problem set 1, which I think you can knock out no problem prior to a week from today. So I think as long as everything else is rolling along, we're in good shape. So I'll just take a break here, and then we will dive right into Chapter 7, Oil and Gas.